What's up, everybody? Welcome back to yet another episode of Basic Chem 101 with Sihle. My name is Sihle, and as we said last week, today we are doing naming of compounds, that is nomenclature, part 1. Let's go.
Let's go. This is for every child that wants to make it one day. Izimbo class and presence of mind is elsewhere. Finger usuzani afuna kuhle dlale. Already alisibani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they the written and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help me.
Can you imagine that back in the day, when people found new compounds, they would name them after themselves or after the place that they discovered those compounds from, or they would name them based on the properties that those compounds do. For an example, sodium sulfate was named after J. Glauber. It was named as Glauber's salt, and there was sal ammoniac, which was named after a place in Egypt. So imagine if I had to find my own compound back in those days. Maybe I would name it Sihle or Geltinated, based on my mood that day. So, but you'd find that as time goes, we would have a problem in finding the correct names because we always duplicate our names. So we duplicate compounds. So there was a system of naming compounds, which was nomenclature, which is what we are looking at today. And we are basing on simple compounds. And also, since this is part 1, we'll be looking at ionic compounds. Maybe next time we'll be looking at molecular compounds and how you name those. So let's go and check how do we name, or how do we go about in understanding the naming of ionic compounds. So we are naming simple compounds, and we are focusing on ionic compounds. So naming ionic compounds is fairly easy. You just have to name your ions as they appear. For an example, if this is aluminum sulfate, so this is your aluminum ion, then this is your sulfate ion. So this is aluminum, which is aluminum, then this is sulfate. So it's fairly easy like that, but it happens that sometimes you don't have, this is your cation, right? Then this is your anion. Because aluminum is a single element, so this is a monatomic ion, but this one is a mixture of sulfur and oxygen. This one is a polyatomic ion. So with this in mind, there are certain rules that are followed when you are naming simple ionic compounds. So let's get to that. As you would know, your ionic compounds are mostly your metals bonded to non-metals. Your metal being your cation, your non-metal being your anion. So there are rules in predicting the charges of your metals and the charges of your non-metals. If you focus at main group metals, usually the charge of your metal is the same as that of a group number. An example, sodium is in group 1. So sodium would usually be Na plus. Calcium is in group 2. So calcium would be usually Ca2 plus. Aluminium is in group 3. It will be usually Al3 plus. Those will be your main group elements. If you don't know main group elements, go to our video which is on the periodic table. We will link it up. So this is usually the case when you are predicting the charge, but there are high atomic number metals like your lead. You find that they do not only have one charge like the group number. So you'd find that lead is usually the group number minus 2. Lead is in group 4 and it is a main group element. So group 4 minus 2, find that lead is usually Pb2 plus, and also it can be lead 4 plus. So it has more than 2 elements, or it has more than 2 charges. And then you find that you have transition metals. Transition metals usually have more than, just like lead, usually have more than one charge. For an example, your iron comes as 3 plus, your also 2 plus, your copper is usually copper plus or copper 2 plus. Then the fourth would be your anions. Your anions, which are monoatomic. Remember we had polyatomic anion, which was sulfate. Now a monoatomic anion would be your Cl minus, or your O2 minus, or your N3 minus. Predicting this charge would be 8 minus, it's actually group number minus 8. So oxygen is in group 6. Group 6, or it's 6 minus 8 is negative 2. Chlorine is in group 7. So it's 7 minus 8, you get a minus 1. So that's how you usually get your charges for your metals and your non-metals. So let's get to how you usually name your ions when you're going to, how you usually name your ions when you're going to name your actual ionic compound. So your metal, let's say your aluminium 3 plus, you usually call it your aluminum ion. Your magnesium 2 plus, you use its name, which is magnesium ion. Now remember, these are your main group metals or your main group ions. You just use the name of the element, and then if it has a charge, it's an ion. But if it now has more than one charge, like ion, which is Fe2 plus and Fe3 plus, now this won't give us what we are looking for. So for transition metals, or for metals that have more than one charge, you would use Roman figures. For ion 2 plus, you would indicate the charge, which is 2. So this is ion 2 ion. Then this one is ion 3 ion. And then for your monoatomic N ions, let's say you have Cl minus, you have O2 minus. You don't just write its name like we did for metals, but for chlorine you change the last letters to "ide", so it's gonna be your chloride ion. For oxygen, it's gonna be your oxide ion. Let's say for nitrogen, it's gonna be your nitride ion. So with that in mind, you also have to, I don't know the exact way of really knowing the polyatomic ions, but you have to familiarize yourself with your polyatomic ions here. An example would be SO4, this is sulfate. Then this one, is it 2 minus or 3 minus? I don't know. It's carbonate ion. So if I have something of this nature and someone says I must name this, then I have something of this nature. Someone says I must name. Then someone says I must name this. This one is your sodium ion. This is your chloride ion. I just drop your ion, which is, this one is sodium chloride. Then this one is sodium sulfate. So if you know how to name your ions, you just add your ions to get the chemical name for ionic compounds. And that is about it. Let's do, if you have something of this nature, let's say this is ion. You have copper. For your transition elements, you will always be told which charge is there. So they will say, give us the chemical formula. So this is ion 3. So you have Fe3. Then you have SO4 2 minus. So this would give us Fe. From our last lesson, you would know that this is Fe2SO4, which is iron sulfate. And then this one, copper chloride, would be Cu. So this is 2 plus, then this is Cl minus. So this would be copper chloride. Then that is your naming and your formulating of ionic compounds. We end there. Thank you very much from this side. So I hope you got the gist of what we were talking about in naming ionic compounds. It's fairly easy from the way I see it. I hope you saw it as I tried to explain. So look at your examples, further examples, and try to implement what we were talking about, and also look and familiarize yourself with polyatomic ions so that you can be able to move forward in naming simple compounds. So when you get to complex compounds, if you know these steps, it's going to be easier as we move forward. So I hope you got that. So that is it from my side. Thank you very much for watching. Please subscribe, please comment, please tell us what you think and what you think we must talk about in the future. And now we are signing out. Thank you very much. This has been Basic Chemistry 101 with Sihle Bonani. My name is Sihle Bonani. Booyaka!